Good afternoon. This semester I'll be teaching discrete mathematics. In this lecture, we'll look at a brief introduction along with the objectives, outcomes, and the syllabus. Let's begin with the introduction. Why do we need to study the subject discrete mathematics? So, computers use discrete structures to represent and manipulate the data. Now, what do you mean by discrete structures? Discrete structures are basically sets, relations, sets and relations. These two topics you study together in your earlier classes. Then you have a new topic, graphs. This is not the XY coordinate graphs, this is something different. Along with that, you have trees. These are the subtopics of computer science. Permutations. This is something that you have already studied, permutation and combination. Okay. So these are the discrete structures that we use to represent and change the data. Now, why another form of mathematics is necessary in computer science? So computer science is not just programming. Okay. So if you learn all the programming languages and master it, that is not sufficient to be a computer science engineer. Also, it is not simply software engineering. Okay, computer science is about problem solving. Now, what do you mean by problem solving? Whenever you join the industry or the corporate sector where you will work as a computer science engineer, you will be required to solve problems. Now, what do you mean by solving problems? Let's look at this. Mathematics is the requirement that is necessary for problem solving. Okay, mathematics is not simply the solutions but also defining a problem. So, defining a problem is also requiring mathematical accuracy. Now, in computer science, we use data structures, algorithms to build a foundation of mathematics in such a way that we'll be using the earlier mentioned discrete structures, the ones I mentioned in the earlier slide, that is permutations, combinations, etc. Now, once you have defined a problem, given a solution, the other important step is justifying why your solution is correct. Okay, so suppose if there are 4 engineers working and all 4 of them give 4 different solutions. Now, you have to say why your solution is efficient or better. You have to justify that. For that, we require discrete mathematics. We require a mathematical model which will give logical reasoning to why your solution is efficient. Now, let's take an example. I'm taking an example of cab company, and it has hired you as a computer science engineer, and the requirement is that they are asking you to write a program. Okay, they are asking you to write a program, and why do they want to write the program is they want these tasks to be automatically done. Now, what are the tasks? First is businesses or customers request their cabs and drivers. Okay, now they request the cabs and drivers for some amount of time, and they also specify the start time and the end time. The customers will specify the start time and the end time. Along with that, they will also mention at what rate. Rate means what is the amount they are giving for every kilometer or hour. They also mention that. Now, here task is to generate a schedule that accommodates the maximum number of customers. So the task for the computer science engineer is to give a schedule which will give the maximum number of customers. Okay. Now, apart from that, any company does not just want the maximum number of customers. It also wants something which is profits. So it also wants something which is profit. Now for that, let's see the task 2. In the second scenario, the cab service is allowing the customers to auction or give a bid. So when you even hire an auto, so in our city, what we do is we hire an auto and we try to give a rate in such a way that it is feasible for both the customer and the driver, right? Similarly, over here, any company wants profit, and for that reason, they want the highest bidder to get a cab. Okay, so now there is another criteria added, that apart from the maximum customers, they want maximum profit. And also, one more thing which is obvious is the feasibility. What do you mean by the feasibility? That is, whenever you are giving a cab, each cab must be given to only one customer. So if there is one cab, it should be given to one customer. Okay, one customer. So that is another criteria. So by now you have got three criteria. The first one is maximizing the customers, right? So we have seen that in this slide, maximum number of customers. The second criteria is the total profit, and each cab should be given to only one customer. Now, how will you give such a program? So our job at the end is to build a model and develop an algorithm. So we have studied algorithms earlier, I believe. So we have to develop an algorithm and also justify your solutions. So now, whenever you're designing algorithms, and these are a few things that you've already studied, that each algorithms must end somewhere. Okay, it should be complete. That is, the algorithms should find a solution, and the solution of your algorithm is correct, which is soundness. So end or termination, then it should be complete and it should find a solution. Then the solution should be correct. Also, your algorithm should give maximum profit or maximum customers. So that is known as optimal solution. Okay, maximum or minimum, or give a solution which is beneficial for both the customer side and the business side. Apart from that, it should be efficient. Now, what do you mean by efficient? It should finish at some given amount of time. Okay, so that is efficiency. So these are the things you have to look every time you design an algorithm. Okay. The next thing. Now, what is discrete mathematics? What do you mean by the terms individually? So discrete is basically distinct, unconnected. Okay. So whenever you have numbers, when you study numbers, you study different types of numbers, right? There is real numbers, integers, natural numbers, all different kinds of numbers. Now, real numbers can be considered continuous, okay? While integers and natural numbers are distinct. You have 1 and after that you have 2. You don't have 1.1 in the middle in the case of integers or natural numbers, okay, in this case. Now, what do you mean by the term discrete mathematics? So it is a collection of mathematical topics which use finite mathematical objects or which can be counted. So it should either be finite or it should be counted. That is, we can count them. It should not be infinite and it should not be continuous. Okay. Now let's look at the official textbook definition. So discrete mathematics is the part of mathematics and which involves the study of discrete subjects. Okay, discrete means again distinct or unconnected. Now, what kind of problems do we solve using discrete mathematics? What are the different branches? So, parallel computing, parallel computing, cryptography, information security, all these. So, discrete mathematics, like a programming language, is the basis for the entire computer science. Now, if you look at the different examples, these are just the basic examples given, which can be solved using discrete mathematics. How many ways are there to choose a valid password? So this is a part of permutation and combination, if you remember. Then, what is the probability of winning a lottery? So this involves probability. Now, how can you identify spam email messages? So this involves the concepts of keywords. The next thing is shortest path between two cities, and you can read the list of examples. The next thing, what are the areas in discrete mathematics? So I'll cover your syllabus, but I want to give you a general view of what are the different areas. So first is logic. Logic is used in artificial intelligence, databases, circuit designs. Counting. Counting is permutation and combination along with probability. So that is used in probability and analysis of algorithms. The next one is graph theory. Graph theory involves graphs and it is used in computer network and data structures. So this entire thing is basically what are the different topics and where are they used. Okay. And this logic, sets, functions, relation, these are the topics. These are the topics. And these are the branches where it is used. Okay. Now, let's go with the course objectives. So what is the objective of this course? So we are supposed to learn the mathematical concepts. So mathematical concepts involve reading, understanding, and giving a solution for mathematical problems. Also, logical problems. Logical problems is what we'll study in the first topic of this course. So, mathematical concepts to learn and solve logical problems. The next objective is to model relationships, analyze data, and apply probability concepts. So, relationships and analyzing of data. Whenever we have data, and what we have to do is we have to analyze it. So data sciences is a huge branch which is trending right now in computer science, and data sciences is basically analyzing of data and creating some connection between the vast amount of data that is given. Apart from that, we also use probability concepts to solve our problems. So what is the probability that a certain solution is the efficient solution? Those kind of things. Next is to develop mathematical skills. So to develop mathematical skills is certain problems in mathematical sciences, which we'll study later in the next semester or so, require higher mathematical skills, and those are advanced mathematical skills. So we'll study a few basics of that. These are our objectives. Next, what are the outcomes? So at the end of this course, you will study propositional and predicate logic, which is our first unit. I don't want to begin the unit today, so I'll keep it for our first class, propositional and predicate logic. Why do we have to learn that? These topics are very important in various branches of your computer science. The next thing is set theory. Set theory is something that you have learned earlier. Venn diagrams, relations, functions. You have studied them theoretically, but in this subject you will learn how to apply them in the real world scenario. So this is our first and this is the second outcome. Now, the next thing is generating functions and recurrence relations. This is unit 3 and it covers your, if you remember, there is something known as recursive functions in C. So the recurrence relation is the mathematical side of, so this is similar to recurrence functions. After that, we have graphs and trees. I know you have been hearing the terms a lot. I'll explain it as and when we get into the subject. And then whatever we have studied in all of these topics, we will study partially ordered sets. So this is basically a topic in relations. In relations, let me write the whole thing. And after that, we have the final outcome is whatever we have learned, we can apply to various discrete mathematics problems. Okay, the next thing. Now, what includes the syllabus? So the syllabus of discrete mathematics is first we have to study propositional and predicate logic along with sets, operations, functions, and a bit of number theory, algorithms, complexity of algorithms, etc. After that, in logic sets and functions, the topic sets and functions is something which has been already covered. The only difference is we'll learn how to apply this topic in computer science. Also, algorithms have been covered in C programming, and the same thing we'll learn how to apply the algorithms or how to connect the algorithms with real-time problems. Similarly, algorithms is another topic that you'll be studying in a different subject, which is data structures. So a few of the topics will merge in both the subjects. Next we have integers and division. Okay, you might think that this topic is being studied in 5th standard, but here we will learn how we do the division of binary numbers and what is the concepts that are required in computer sciences. The next thing, now why do we need this first unit? What is the requirement? Here, logics and proofs, so predicate logics and the number theory, so both the first and the second part, we need them because we have to understand the thinking of a computer. The reason being, whenever we are designing a computer, we have to understand that how is the design of a computer, how the design of a computer should be given in such a way that it performs the task correctly. So this topic, logic and proofs, is required in these branches: artificial intelligence, database, circuits, algorithms, and there are a few other branches, but these are the ones you will study in later years. Now, what do you mean by logic? Propositional logic and first order logic. And why do we need the proofs? So we will study mathematical induction. So this was the topic that you have already studied. We have to give proofs. So mathematical induction will even cover a bit of that. So logic and proofs is for that. Now the next unit, mathematical reasoning. Mathematical reasoning, induction and recursion. So mathematical reasoning is how are we giving the proofs and in what way should we design the proofs, proof strategy. Then we are given sequences, and so if you remember your arithmetic progressions and geometric progressions, the summation of those are in sequence and summation. Then we have mathematical induction, as I was just saying earlier. Along with that, we have recursive definition, structural induction. These topics are a bit advanced. We will see them as we go into the chapter. Next. Next things, I'm just introducing you to the topics that you already know so that you understand that the subject is not entirely new. You're learning the same topics, almost the same topics that you have already learned, and we're just seeing the application of those topics in our branch. Now, permutation and combination, binomial coefficient, all of these are something that you know. So that the permutation and combination is NPR, NCR, and binomial coefficient A plus B whole power n, etc. Apart from that, generalized permutation and combination. So it's a part of permutation and combination which we'll see further. So counting. Where is counting used? In probability, algorithms. So I think you have learned sorting algorithms or counting the n numbers, sum of n numbers, count the sum of n numbers, all these kind of algorithms. So we'll be learning the same things, but also along with that we'll be seeing the complexity, how much time, whether the algorithm is efficient, etc. And also if you remember, we used to have these topics and probability, the pack of cards and selecting different balls, etc. So it's the same kind of problems we'll be looking over here. Next, number theory. Number theory is sequencing of numbers, prime numbers. So these kind of topics, if you're wondering where they are used over here. Cryptography, coding theory, data structures. The next thing. The next thing is discrete probability. So discrete probability is probability, but we are looking only for discrete numbers. So discrete numbers, if you remember, distinct. So I'll just mention it over here. Distinct. Distinct. So we'll be dealing with probability only with distinct numbers. Then we have advanced counting techniques. So a continuation of permutation and combinations. So this topic is continuation of permutation and combination, where we'll be studying recurrence relations, divide and conquer relations, generating functions, etc. Now, next, Unit 4. Unit 4 covers the topics of relations. So relations, if you remember, is a continuation of sets. So this is a continuation of sets. So along with sets, we'll be studying relations, their properties, and other things with respect to relations. After that, we have graph. So graph is basically when you have 2 points, you have something known as vertices and edges. So if you have two vertices and you're joining them, with a line which is an edge, that is a graph. Okay, so with respect to this terminology, I have an example of a graph in the next slide. But with respect to this terminology, we will be studying various topics related to graphs, graph isomorphism, connectivity, and to find a shortest path. If you remember, I've given the example in the first slide to finding the shortest path between two cities and graph coloring. Okay, the next thing is graph theory. Graph theory, it includes these kind of graphs. So whenever we have um, a network of computers, we have the network of computers. In that case, we will join those computers in the form of a graph. So the computers themselves are vertices. So the computers themselves are vertices, and the links between the computers will be the edges. Okay, so this is a rough example of a graph. We'll study graph while we get into the subject. Similarly, we have trees. So trees is a subpart of graph. So the graph theory is used in these topics: computer networks, circuit designs, data structures. So if you notice, data structures is frequently appearing in our subject. So data structures and discrete mathematics are quite connected, even with respect to a few of the topics. The last chapter of both discrete mathematics and data structures is very similar, and the syllabus is in such a way that most of the topics of discrete mathematics are similar to discrete data structures and also digital electronics. If you notice the last chapter, we will have logic gates, Boolean functions, the second part of this chapter. This is similar to another subject which is digital electronics. So there is an overlap of a few of the topics of this subject along with a few other subjects, and that is also the reason that you will understand that this subject is quite important with respect to creating a base for future. Now, so trees are something that we have already covered. The next is Boolean algebra and Boolean function. Now, which textbook are you supposed to refer? The textbook which you are supposed to refer is Discrete Mathematics and its Application, 5th edition, and it's published in the year 2003. This textbook covers all the topics. The one that I have underlined covers all the topics of your syllabus. Also, there is a new edition, 7th edition. Yeah, one more thing. The 5th edition does not have the discrete probability. So discrete probability is not present in the fifth edition. So I'd advise you to go for the 7th edition. So 7th edition has all the topics, and the 5th edition does not have one topic. And if you want to study any further, if you want to develop an interest in the subject apart from your syllabus, you can refer to the other 3 textbooks that have been given. And this is the end of today's lecture. Let's just have a quick summary. So we studied why we need discrete mathematics. Next, we studied what is discrete mathematics. After that, we looked at the example, the cab company example, and after that, it was course objectives, course outcomes, So I'm writing course objectives, course outcomes, and we looked at a brief overview of the syllabus. That's it for today. Thank you.